green's on. There. Good morning, all. My name is Bill Humber. It's my pleasure to be your MC, and it's my distinct pleasure to turn the introduction over to Mary Vaughan, the Dean of Business and co-chair with myself of Seneca College's Environmental Sustainability Committee. Take it away, Mary.
Thanks, Bill. I was going to use my teacher voice, though. I was good. And thank you so much. It is a great honor to welcome everybody here on day 2 of the Global Citizens 2019. I want to say a special thank you to TD Insurance for their outstanding sponsorship for this symposium. TD is a great partner of Seneca, and we have a long history of collaboration on very important societal needs, and we share a common goal on climate. It is through TD's leadership on climate resilience and the insurance sector that we're able to advance our pursuit on climate sustainability and protection. Thank you so much, Huma Pavani, and we really appreciate your support on this vital needs for the success of this conference, so thank you. A very special thank you as well to Helix and to the Helix speakers that will be here today for their contribution to their workshop that you'll be experiencing today. And thank you very much to Bill Humber and to the full, and Andrew, and to all the planning that's gone into 3 days. And when I was listening to Andrew talk about this being the 9th year of this Global Citizen and how it started from a one session and now into 6, it's just absolutely incredible, and it really speaks to what you've been able to achieve in terms of pursuing our interests here on global needs for the climate. This year's theme, Climate Resilience, Global Problem, Local Solutions, speaks to the importance of everyone in ensuring our climate is protected and not further damaged. We collectively have the responsibility to do our part, and no part is too small. It is boundless, ageless, genderless, and transcends the globe. We're all facing this problem, no matter where you are, from the north to the south, to the east to the west. This fall, we saw the impact that the climate strike had on the world when they all took to the streets, making it the largest mobilization climate event in history, with 7.6 million people striking for climate action. Around the world, people spoke about their demands for climate defense. And the global strike speaks really clearly to what the symposium is all about. It's about the empowerment and speaking what's really important to us and to our needs. And what I found really interesting was that in Ottawa, more people were striking for global change than were there for Canada Day. That's really just absolutely speaks to where, how this really impacts everybody. Also, too, one aspect that I like to think about is the local solutions. We know about all the global needs that we have, but local solutions build up to our global solutions. So we collectively have to all work together on local solutions, and they can have a significant impact. And if we couple these with putting pressures on policymakers, we'll get what we need in terms of climate priorities. We can all be the Greta Thunbergs in our communities. And I challenge us all to take that stand. And no time has ever been more crucial in our history than now to advance this need. So Seneca works very hard on global sustainability, global needs, and global climate change through our sustainability committees, the work that our students are doing, the work that our faculty are doing, as we pursue our what we would see as our responsibility in this very important area. So I'd like to welcome you all here. I hope you have a wonderful day, and I hope you enjoy all the great speakers that you're going to have and spend lots of time networking. Thank you.
Thank you very much, Mary. So that'll be the message for today. You can be the Greta in your community. So anyway. So before we begin, I want to acknowledge our place in this particular landscape. If we could bring up the message, Seneca would like to acknowledge the land on which its buildings are housed and where students, faculty, support staff, and members of the public gather. This land is a traditional territory of the Mississaugas of the Credit First Nation. We are guests on this space, and it is our shared obligation to respect, honor, and sustain the land. So we very much appreciate that message. And I'd now like to turn it over to the president of TD Insurance to give us some words of greeting as well, if we could do that.
Hello everyone, on behalf of TD Insurance, I'd like to welcome you to the 2019 Seneca Green Citizen Symposium. I'm sorry I can't be there in person, but I'm very happy to be able to share this message with you. We're very proud to be the presenting sponsor of the Green Citizen Symposium again this year. TD's purpose is to help enrich the lives of our customers, colleagues, and communities. At TD Insurance, we know all too well the negative impact of severe weather and climate change on people's lives. We have an incredible opportunity and responsibility to take meaningful action to address climate change and build resilience in the communities where we live and work. Every day we strive to better protect our customers, but our commitment goes further than that. TD Insurance is leading and participating in several local, national, and international activities that focus on climate change and the impact of severe weather. We are signatories to the United Nations Principle for Sustainable Insurance and participating in the UN-led pilot to implement the recommendations of the Task Force on Climate-Related Financial Disclosures. Through that pilot, for the first time, insurers around the world will be publicly disclosing their climate-related risks. But we know we can do more. This year, TD Insurance established an advisory board on climate change, a first for the Canadian insurance industry. Bringing together experts in fields related to climate change, our goal is to make a meaningful impact in increasing the resilience of Canadian communities. And most recently, TD Insurance sponsored and took part in a restoration program to improve biodiversity and increase flood resilience along the historic St. John River in New Brunswick. At TD Insurance, we share your commitment to leaving the world in better shape than we found it for generations to come. That's why we are so proud to be part of important events like this symposium. There's a tremendous amount of learning to be had over the next few days from leaders in a variety of fields, including a couple of my colleagues from TD Insurance. You're here because of your passion and your dedication to building a better world. We can all feel more confident about what tomorrow will bring, knowing we are in the hands of emerging leaders like you. I hope you enjoy the symposium.
And again, thank you very much to our friends and colleagues at TD Insurance. I just want to highlight Dean Hughes, who works very closely on our behalf with TD Insurance. Dean, just wave your hands there. We have Kathleen Galen, who's the chair of the department in which your programs are situated. For those of you who are in civil, environmental, fire, and other related disciplines, wave your hands there. Colleagues who will be working with you in the second half of this morning will be an exercise, and a couple of things I just want to point out to you before we proceed on that there's an expectation that you make sure you sign in when you come so you get proper recognition and acknowledgement from your faculty, and there will be an exercise that you'll be submitting, and again, Andrew Wickham, and wave your hands there, Andrew, kind of the brains behind the operation. He'll ensure that those are collected from you as well. We have Glenn Miller, a good friend and colleague in the back row, and a fellow supporter of West Ham United in the Premier League for those of you who follow soccer. That's just my aside. And Sally Moore, our scribe, in the corner as well. And we've mentioned some of the other folks that are here with us today. So one of the things about the changing conversation and the evolving is maybe a better word on climate change and resilience is the fact that we we've gone from a period in which, on the one hand, we had denial on some sides of the equation, and on the other side, we had despair for people who felt that there was nothing we could do about this. We're actually here into doing, into deployment, into making things happen. And so the speakers that make up a part of these 3 days are really about that process of actually doing and engaging you in such a way that you're able to act as well. And towards that end today, your keynote speaker will be Matthew Tukarik. Matthew is a professional engineer, has a master's in science. He works with designers, builders, and developers across North America to deploy, there's that word again, geothermal heat pump and renewable energy systems through financing and installation services in pursuit of significantly reducing greenhouse gas emissions and ultimately reaching net zero building operation. He has previous experience working as a building energy consultant, developing energy and carbon reduction strategies for buildings and communities. Matthew is actively involved in the North American passive house community and is passionate about extending passive house construction practices to the commercial market as a primary means of reducing heating and cooling loads. He's also a sessional instructor at Ryerson University and McMaster University, where he leads courses and seminars in sustainability, building science, and building energy use. Matthew, take it away, please.
Thank you. Okay. Thank you very much for the kind introduction, and thank you all for having me here this morning. Like we mentioned, I come from the engineering world myself, and so I'm really excited to be here with folks like yourselves. We are kind of the boots on the ground of this movement, and the politicians are out there talking about big changes, but we're the folks who are actually gonna make this stuff happen. So I'm really excited to be part of the event here today, and I'm really excited to sort of help think about these problems with you guys as we move into our sort of next generation of how we're going to tackle these problems, and that certainly rests on all of your shoulders. So for the last number of years, I've had two big problems on my mind. The first one being, how can we bring high-performance buildings to the mass market, right? How do we get adoption for this high-performance stuff into the market at a mass scale? And second, why have we not succeeded yet, right? We've got all of this, headwinds and tailwinds kind of pushing us to these solutions. I don't know if you guys were aware of this stat, but Canada is one of the worst carbon emitters per capita. So if we look at the broad scale, and particularly in sort of the G7 and G20 sector, Canada is actually one of the worst carbon emitters per capita. So when we look at the mirror, it's really on us to start to do something about that. Another important factor that sort of goes into what I do and what we're talking about in the building sector is the fact that our buildings in cities like Toronto and in other urban areas are actually responsible for over half of the greenhouse gas emissions. So 52% as of 2017 in the city of Toronto, carbon emissions, GHG emissions, are actually coming from our buildings. The other significant pieces there, of course, are transportation and waste. And really the biggest factor of that, the biggest part of that is heating our buildings for space conditioning and for domestic hot water. And so that largely comes down to combustion in our buildings, right? We've got these big natural gas boilers that we use to heat our spaces and that we use to condition our domestic hot water. So really big area for opportunity here, obviously in the building sector, particularly in the way that we heat, specifically in the way we heat our buildings. Our mayor, John Tory, declared a climate emergency. This was something that was unanimously agreed on by City Council. I can't remember the last time that City Council agreed on something unanimously. So obviously there is a lot of, let's call it, political, societal, and even economical drive to make these projects happen, to make our buildings cleaner, to reduce our GHGs as a whole. Our commitment has once again been declared by the city here that we need to reach our 80% reduction targets by 2050. So this is getting taken very, very seriously. So again, what is it that's actually holding us up? Why have we not gotten there yet? So one of the challenges is defining what high performance building is. I sort of left that ambiguous because different folks have taken a crack at defining this, and everybody has sort of different beliefs on how we should go about reaching the masses. And certainly there have been a number of efforts that have worked already, and have continued to drive this movement forward. So first of all, I just want to sort of define the problem here. Let's take a look at some different types of high performance buildings, and we can discuss sort of the pros and cons of getting there before we talk about how we actually implement these things. So the first one, that's near and dear to my heart is Passive House. So Passive House is a standard that comes from the Europeans, specifically Germany, in the early 90s. And these folks are extremely concerned with energy efficiency, right? It's all about reducing our building loads drastically, such that we use, a small fraction of energy relative to what the norm would be, up to 90% savings over a benchmark. So really, really interesting stuff. These guys have very rigorous standards, but on the flip side, it's often hard to get certification. This is sort of the gold standard, the top tier of where energy efficiency can get to. Although it's sort of based on really good building science fundamentals, you still have to get certified pieces, components, windows, HRVs, things like that, which makes this a bit of a challenge and a bit of a something that's not necessarily for the masses quite yet. There's still a lot of barrier getting in between us and this final product. But it can be done here. This is a project that's local, just kind of down the street here at Humber's North Campus. This is building NX. Really, really interesting project. The folks over there are really leading the industry, I would say, and they decided to take this old building that was built in maybe the 70s or the 80s. It had a beautiful glass block facade that was absolutely leaking heat. And they retrofit this building, and it's going to meet the International Passive House standard. It's I believe still under construction, and one of the reasons for that is the fact that they had to order all of these Passive House certified windows. So that can really hold up the process. And again, when we're trying to get these buildings out to the masses, putting barriers like that in front of us can be a big challenge. So it is doable, but it becomes a challenge on its own. The other part of this that you have to remember is that we've not necessarily gotten rid of all of our energy, right? We've significantly reduced it, but there is still a fraction of it that's going to remain. So again, if we start to think about getting to the next level, we can start to think about things like the Living Building Challenge from the International Living Futures Institute. There are many sort of pedals to the Living Building Challenge, but one particular pedal that is of interest to us here in this discussion is the energy pedal. So to be certified as a Living Building Challenge building, you have to prove that over the course of a year you have produced as much energy on site as you have consumed, and no combustion is allowed. Again, this is a really, really interesting standard. These folks have gone to the nth degree to make sure that not only the energy is taken care of, but things like net zero water on site, net zero waste, a really strict red list of materials that are not allowed to be used. Again, this is not really the standard for the masses, I don't believe. It's actually quite a hard challenge to get to. If you do get there, you get the gold star. It's kind of the best we can do, but there's still a fairly big hurdle to us getting there. Some of you folks may have heard of this building, the Bullitt Center in Seattle. Many folks say that this is the world's greenest building in terms of energy use intensity. If that number means anything to you guys, this thing's down in the 60s kilowatt hours per meter squared. Really, really efficient. And you can see it's got this sort of distinct mushroom shape to it that is, kind of the rooftop solar panels that are filling the or are needed to offset that energy. So hold that in your mind for a minute. We'll come back to the discussion about photovoltaics again here in a second. But just sort of consider the shape of this building and how much PV you actually need to get to net zero. It's quite astounding. So as we shift into this discussion about getting to net zero, obviously that's our target goal here is to address this problem. We know we've got all of these emissions, and so we can either get a building to be net zero to obviously reduce emissions if there's no energy being used or no net energy being used, there's no carbon emissions associated. And so the U.S. Department of Energy in the States came up with a definition a few years ago that says a net zero building is a building where on a source basis the delivered energy is less than or equal to the energy exported from site. So again, this is kind of our gold standard, our top tier for reaching net zero. If you are a net zero energy building, again, you're not going to be associating any emissions with that building. But quite a challenge. So we'll come back to this PV discussion here in a second. If we look at an example of one of these buildings here, this is the NREL, the National Renewable Energy Lab in Colorado. Really cool research facility. If you guys are ever in the area, go and check it out. They've got some really interesting lab spaces in the building. But they're fortunate to have an entire sort of site surrounding them where they can start adding PV and different sort of renewables onto the campus so that they can power this building. So this brings me to kind of the last definition and sort of the one that I feel is kind of the right one that we should be targeting, and that's the definition of zero carbon. Okay, so the difference here when we're talking about net zero energy versus net zero carbon is that net zero energy asks you to be totally zero in terms of your energy production. So over the course of the year, all of the energy that you consume in the building must be offset with the equivalent amount of energy. When we're talking about carbon, things are a little bit different, right? Instead of offsetting all of the energy that you have with renewable energy, you just have to make sure that your carbon balance is equal to zero. So this means that you can still use energy on site. You may not even produce all of your energy on site, but somewhere else, this could be down the road at a solar farm. This could be buying renewable energy specifically from a hydro plant. Somewhere else, you need to be making sure that the accounting of the carbon is balanced out to zero. Okay. And so, an example of this is the Mohawk Center, also down the road here in Hamilton. Really, really interesting project that was just built, just finished not too long ago, maybe a year or so ago. They've had a lot of attention and a lot of media, so some of you may have run into this one. Really high performance institutional building, and certainly something that in my opinion is achievable for a lot of our buildings. So, I guess I've sort of given the answer away already here, but which approach of these is correct, right? What are we trying to achieve? And when we're trying to think about getting out to the masses here and getting these high performance buildings into the market, which approach is the right one? Well, it depends, right? It depends on what our goals are, and so let's kind of shift down and discuss what the right reasons are. So just take a second here and think about again, why are we doing this in the first place, right? What is it that are we trying to achieve? Are we trying to be the best building? Are we trying to put the gold sticker on our door and saying we're certified by X, Y, and Z? Certainly, for some people that is the case, right? There are certain folks who do want to have the certification and they want to be the leader and they want to show that they've done the work and they've put in the effort to set the trend. But in my opinion, that's only part of the problem. The real problem that we're trying to address here is, what we're all out here for today, and that's this issue of climate change. So, I'll just go over a little bit of the background of what's happening here so that we're all on the same page. This is a graph from the folks at NASA. If you guys have not looked at the NASA website, there's a lot of really, really interesting resources around climate and some really cool infographics and satellite imagery that you guys should go check out. This is a graph showing our average temperature of the globe over the last 100, 200 years, basically since the start of the industrial era. And what we've noticed is that we've got this trend of average increased warming, and the IPCC has noted this too and come up with a lot of reports that have said we are at a point now where we have reached approximately 1 degree Celsius of increased warming on average, and if we keep at this continuous pace, we're going to reach a 1.5 to 2 degrees Celsius increase between 2030 and 2050. And so, we're starting to see these trends year over year where it's hottest year on record, extreme temperature broken again, dry seasons, forest fires, all this sort of stuff is really starting to come to the forefront. And all of the data is sort of right in front of us. You can see this is a chart, again, from NASA that shows the warming trend over the globe, and it's very striking, right? You can see that that year over year we're continuing to get warmer. And so what's causing this, right? Why are we seeing this trend? Again, we're going to look at some data here. This is a graph over, instead of the last 150 years, multiple thousands of years, right? So this is looking back historically, and you see these kind of oscillations that are caused from natural tilt of the Earth relative to the sun changing a little bit, volcanoes erupting and putting aerosols into the air reflecting the sun. That's all sort of historic stuff that's going to stay or that has been going on historically. But as we approach our modern era, we see this exponential jump in our concentration of CO2 in our atmosphere, and this is what's really, kind of the alarming point here. You can see that our numbers here are approaching 400 parts per million. The big issue here is if we let this CO2 level get above 450 parts per million, we're going to have this irreversible cycle. So it's going to get to a point where the rate of warming is going to accelerate beyond what we can control, and it's basically going to go, beyond recovery to a point where we have, sea rise level that's going to become very dangerous, as well as what they call dust bowlification, so extreme periods of drought leading to water shortage and eventually food shortage. And so, if we look at the science of what's happening here, we kind of start with this image of our Earth and our atmosphere. So the atmosphere is actually really, really important, right? If the Earth did not have the atmosphere around it, the average temperature on Earth would be 18 degrees Celsius lower than what it is, which would basically mean all of our water would be frozen and life on Earth would cease to exist. So this whole atmosphere causing this greenhouse effect, right? We allow the radiation from the sun to get into our atmosphere. It warms the surface of the Earth, and then as that heat tries to escape, it gets captured by the atmosphere. So this greenhouse effect is really one of the reasons why we're all here today. So really, really important, right? Really crucial to our life. But humans came along and started doing their thing and started pumping CO2 and other greenhouse gases into the atmosphere. And so, this again was kind of that period that we saw in the 1900s where humans wanted to industrialize. We started focusing on economic growth at the expense of the atmosphere. We didn't really realize what was happening, but now we've kind of started to see this trend, and it's kind of becoming almost too late if we continue at this pace. So these big coal-fired plants that you see here are obviously one of the big drivers of that, and that's something that we need to change. And what gets really dangerous here is that as we start to inject more and more CO2 into our atmosphere, it actually starts to drive a cycle that is somewhat self-propelling. So as we add more CO2 into the atmosphere from things like coal plants and transportation, et cetera, it starts to warm the atmosphere. That warming starts to melt the ice, and ice, which is light and reflective, instead of bouncing the solar rays back into space. When the ice melts, what we now have is dark water and dark land that will start to absorb that heat energy. So this self-propelling cycle of heating is causing this ice melting, which is causing more heating. So we're starting to see this runaway effect from that. The other interesting piece here is forest fires. So one of the issues with, again, this sort of warming trend is that we've really thrown the sort of atmosphere out of equilibrium, and we're having these dry periods which are leading to forest fire conditions, which ultimately lead to forest fires. And the big deal with forest fires is that these trees here are sequestering a lot of carbon. So they have, during their growth, they've collected carbon, they've collected CO2 for their biological processes. They store them in the wood and obviously release oxygen. As these forests start to burn, they basically release that CO2 back into the atmosphere, and again, sort of propel this change forward. So we've got all this warming happening. We've emitted all of this CO2 into the atmosphere. It's kind of continuing to drive and propel itself. Is it really so bad, right? Is this 2 degrees Celsius, 4 degrees Celsius thing so bad? We're all going to be out on the beach enjoying a longer summer. Well, I would argue that that's not quite the reality. This is kind of what we are going to be faced with here. So scientists are estimating that by 2100, so in approximately 80 years, there's going to be 4 to 6 feet of sea rise. And so think about the cities that are on the coast. Here's an image of a set of data basically that comes from a data group that sells into insurance companies and to real estate companies. Very actually on point with what the gentleman from TD was just saying, is that folks in the insurance, real estate, and risk industries are really starting to take note of this, right? So you can see green means not so bad, red means really bad. You can see the red points are on these coastal areas of major urban cities. So Miami, New York, Boston. These are the areas that are in potential threat of this sea rise. And think about all of the economic and population growth that happens on those seaboards. So again, there's this issue happening, and the folks that are I will say making decisions, these big businesses are even starting to take note. So not only is that sea rise event a potential threat, this risk of destructive of events is another big threat. And I would say that this is actually the biggest issue that we're facing here. So when you think about weather events and climate events, there's sort of an 80-20 rule or a 95-5 rule of destructive activity. So these events like mega hurricanes, there's a disproportionate amount of damage done by very few, right? So the Katrinas, the Sandys, those few hurricanes that typically would happen, maybe 1 in 100 years, that do 80-90% of the damage, are now starting to happen more and more frequently. And so you can see on this chart here, there's a very marked trend of increased destructive events. These are things like droughts, floods, wildfires. This frequency is getting really, really alarming, right? So these what were typically infrequent, unlikely events are now starting to become more and more common, which is really, really dangerous. So more to this point here, Hurricane Katrina, $150 billion in damage, right? This is very, very serious stuff. This isn't just, again, this 2-degree warmer beach day. This is becoming a very real threat. A lot of lives were lost here, and certainly a lot of economic damage was done. The other big one here that's going to be a real issue for us is these multi-decade droughts, or this dust bowlification that's going to be leading to water shortage and ultimately food scarcity, right? So again, this is when it becomes a big challenge, and I'll tread carefully on this argument, because certainly there was a large political issue that was behind this, but the Syrian refugee crisis that we saw a few years ago displaced almost 7 million people and obviously had a lot of global stress on many countries. And again, this was a very political problem. There's obviously some disagreement between the people and the government. But what you may not know is that leading up to this was Syria's longest drought in modern history, right? So you think about a drought that is causing reduction in agricultural production, competition for water resources. This caused people to move from rural areas into the cities. This causes a lot of stress. That stress boiled over and into a civil war. So again, things like that can start to stress economies and can start to cause a really big problem. And so, again, instead of thinking of this 2-degree or 4-degree warming condition where we can all sit on the beach, we need to be careful of this potential future where we have mega floods, mega droughts leading to food shortages, leading to scarcity and competition. And the time is to act now. So here's an image of something that we call a climate regime shift, where our world that we know is sort of living in this left-hand side here, where we've kind of got our atmosphere in an equilibrium where we can maintain the sort of conditions that we're used to. If we shift that CO2 across to the right there and we get out of our current equilibrium and into a new equilibrium, we're going to start to see the damage that I just described there, and it's going to be a very hard, if not impossible, task to reverse that trend. So, when we think back to my original question, why have we not done this yet? This is kind of what the way that I see this problem and saying, now is the time to act. We certainly need to take care of this before we get into this unprecedented climate regime on the right-hand side here. So the other big question, now that we've kind of established, what is the main reason that we're doing this for, is, well, how do we get these design principles adopted, right? How do we get people to buy in? And so, again, these standards that I just discussed are leading the way and setting the example, but I really feel that we need to pick something and that we need to, as a design community, look at these strategies in terms of something that's very achievable. And so I'm going to go through an example here to sort of demonstrate the challenge in adoptability. This text is a little bit wordy, I know, but I've already done the math, so you don't have to pull out your calculator here. I'll just go through this example. The first one is going to be a net zero energy building. So remember, there's a difference between net zero energy and net zero carbon. And so if we take a look at the definition put forth by the U.S. Department of Energy, we'll look at what the numbers say. So if we take a 100,000 square foot building, that's an average to large size institutional building at energy use intensity of 100 kilowatt hours per meter squared, which is quite good. This is kind of the standard that new institutional buildings are trying to target and trying to hit. Anything under 100, you're doing really, really well. With a kind of typical fuel split of 60% electricity, 40% natural gas. Given this situation, we would end up using just shy of 1 million total kilowatt hours of energy over the year. And so to meet this net zero energy definition posed by the U.S. Department of Energy, I won't poll the audience here, but just think in your head, how much photovoltaics do you think you're going to need to offset this building? A few panels, a lot of panels, just put that number in your head. So it turns out the answer is 3,900 square meters of photovoltaics needed. And so that's kind of on the order of like a football field requirement of PV panels, okay? So that's a lot of PV, right? You can see that the investment required there is about $1 million or a little over $1 million to offset all of the energy. And so we've seen examples of this, right? If you look at for example, the Bullitt Center, or even the Mohawk College, which I know I said was net zero carbon, but they're also in fact net zero energy. The trend that you see is that a building of that size, typically anything over 4 stories especially, is almost impossible to outfit with enough photovoltaics to reach net zero energy. And so the trend that you end up seeing here is you have the entire building covered with PV, and then you also have 3 or 4 buildings or a surrounding area also covered with PV. So this, in my opinion, is quite a challenge, and certainly any building that is in a dense urban area that's very landlocked is not going to have an easy time finding this amount of area. Apart from the cost, just the area to actually put this many PV panels on is going to be really, really challenging. So now let's jump over to net zero carbon. Again, remember, we're thinking about the ability to actually deploy this stuff. How adoptable is this? If we take the exact same building, 100 kilowatt hours per meter squared on 100,000 square feet of institutional building, what is the requirement for a net zero carbon building? And so, we're going to take the CAGBC definition of net zero carbon, which was introduced about 2 years ago to the market. You guys can go do some reading on what that entails. But basically it says you must have a minimum of 5% renewable energy on site to offset your on-site energy, but then you can look to other places to get the rest of your carbon offset, right? So that includes basically things like off-site renewable energy, so renewable energy certificates, which is sort of buying the right to the environmental attributes of an off-site generation plant. So if you've got a solar farm down the street, for example, you can basically be buying those electrons to offset the carbon on your building. So again, if we think back to this net zero energy versus net zero carbon issue, and we said that the last example had approximately a football field of PV requirement, I'll give you a second here to just think about what the requirement is for this. And it turns out that it's much more approachable, right? So instead of needing a football field worth, we need 16 by 16 square meters. This is something that you could, very easily put on your roof or on your building somewhere. And the capital cost here is going to be under $100,000. So certainly, if you're thinking about CapEx costs, this is something that's a little bit more approachable. The one difference here is that instead of putting the upfront cost to buy your PV cells, again, you're sort of buying the rights to your renewable energy credit, or with your renewable energy certificate here, you're sort of offsetting in another way, right? So instead of putting the upfront capital investment, you're sort of taking this net zero carbon approach through an operating cost. Now, again, there may be some critics that say, well, okay, you're buying your way out of the situation. I would argue that, again, the net zero energy strategy is very, very unrealistic for most buildings. And if our goal is to reach carbon reduction, this is a much more palatable approach for many cases. And so when we go back to that question, which is the right definition? There of course is no right definition, but in my mind, the question should really be which approach aligns with our objective, which is carbon emission reduction for the purpose of climate change, and what are we going to be able to get to the masses with? And I really firmly believe that the answer lies in a net zero carbon approach. So the next question then is, okay, well, how do we do this? Is this actually something that we can do? Are we going to have a hard time doing this? And so we'll walk through this. And the short answer is that we know how to do all of this already, right? There's no secret technology that somebody's going to develop that's going to change this. We've got a pretty well-defined path to get to this zero carbon point, and in about 5 or 6 kind of points or steps, we can kind of walk through how to get this. So there's this hierarchy that's really important when we're thinking about this net zero carbon design. Typically, when I tell friends who aren't very familiar with this world that we're doing net zero, they think, okay, we're just going to plaster our roof with photovoltaics, and we're done, right? We have a net zero building. That is the exact wrong approach. You have to basically flip that approach on its head. So we'll go through this hierarchy, but I'll just kind of give you the overview of it. The first step is reducing your load. So remember, we talked about that 100 kilowatt hour per meter building. the first step is actually targeting that number. So it's targeting energy efficiency and it's targeting heating and cooling load. Once you've got that heating and cooling load down and you've got those energy demands reduced, then you can start thinking about putting on the right mechanical system and finally thinking about generating on site only after all of the rest of the building is taken care of. So we'll just kind of jump through one of these examples. So the first one, we'll bring it back to the Passive House folks. Passive House, again, is perhaps not the right certification approach if you're thinking about what you want to call your high-performance building, but certainly this is the best approach in terms of building physics, and this is very fundamental in its strategy in reducing your heating and cooling load. So this is things like good insulation, mitigation of thermal bridges, really good windows, really airtight buildings, and good heat recovery ventilation, right? That's going to bring our heating and cooling load down to a point where we can start to address it with a much smaller mechanical system. The next step is to reduce our lighting loads. You can see here's an example of somebody who's got a light shelf that'll help bounce daylight into the back of the room. Interestingly enough, is once you start to get into these really high performance buildings, typically when we think of our average building, the highest load is heating and cooling. Once we start to get to these really high performance buildings, our lighting load often becomes one of the worst energy sucks, right? We get to a point where we can't reduce any lower and still work in a lit room. We're going to be working in the dark. So that becomes one of the highest loads. Same story goes for our equipment load. That's the next piece that we need to do is get, after we've addressed our heating and cooling loads, get our electric loads as low as we can. And so this means, eliminating these pieces where possible. Of course, if you're a data center or a commercial kitchen or something like that, that's not possible. So we look for other ways to use that energy in things like heat recovery, or load sharing, where we take that heat that would have been rejected from one zone and put it into another zone. Okay, after we've addressed all of that, we want to start looking at a super efficient mechanical system. This is something that we'll jump on a little bit more in depth in a minute here, but instead of putting our natural gas boiler in that's 70, 80, 90% efficient, if we can start to look at a heat pump, all of a sudden that efficiency goes from 90% to 300%, 400%, right? So some really interesting technology out there that allows us to drastically reduce the energy required for our heating systems. The other really cool thing is particularly in provinces like Ontario, British Columbia, Quebec, where our electricity grids are quite clean, right? They have a lot of renewables on them, or in Ontario's case, we have a lot of nuclear energy. Switching to electricity is a really good way to reduce our carbon emissions, right? We fuel switched from that on-site combustion to clean electricity, so we get a bump in our emissions reductions there again. And then finally, on the broad scale, once we go beyond the scope of one building, we want to start looking for opportunities to get into district clumps here. So this is kind of an example of something that would be an excellent case where we've got a really big IT load, for example, from a Facebook or a tech company that would have a bunch of servers in it. If instead of, again, rejecting that heat, taking that heat and putting it out into the atmosphere, we can start grabbing that heat and putting it into our neighbor's building, which is asking for that heat, we can start to do some really cool things. The other way to do that, of course, is with this district energy system where we save on infrastructure and can have a more efficient system to distribute to sort of the local community. So once we've addressed all of those pieces, then and only then do we want to start looking at renewable energy, right? And so there are tools like PV watts or other online calculators, or you can go into your textbook and figure out how to do this. But once we've gotten the loads as low as we can, then we want to start thinking, okay, how much room do we have on the roof or adjacent land to start putting on PV? There are certainly other renewables like solar hot water. You've all probably heard of wind and these sort of other things. Typically, bang for your buck, PV is the way to go these days. not only in terms of economic reasons, but in terms of load matching. So solar hot water, for example, you have a lot in the summer, you don't need that much in the summer. You need a lot in the winter, but you don't get as much in the winter. So generally speaking, our renewable energy strategy on a building scale is going to be photovoltaics. Once you can start going, outside of your boundary, you can start to look for things like bigger generating production plants. And then the sort of last piece of this is again, I mentioned this kind of competing strategy between photovoltaics or on-site renewables and renewable energy certificates. And so, the general approach here should be, if we're going to try to get to this net zero carbon, you want to balance that space requirement and capital outlay requirement with how much you can put onto your operating side to sort of buy your clean energy at a bit of a premium. So the last piece of this then, once we've got this formula, is to ask how much it costs. Obviously, that's one of the biggest challenges, and certainly in my world, this is always one of the biggest hurdles that I always hear, right? Yes, this is great. We know we want to get to net zero, but how much does it cost, right? And especially when you're talking to real estate developers, the dollars and cents are always on their mind. And so we've got some ways to approach this. Obviously, with good engineering, you can do a design of A versus B and cost those out and compare them. But we've also got some work done by the City of Toronto, some consultants who they worked with, started to put together these sort of tables that said, okay, this is the Toronto Green Standard. Lisa King is speaking tomorrow or Thursday or Friday, and she'll probably tell you a little bit more about the Toronto Green Standard. But this is basically the minimum standard for getting a new building built in Toronto. And the standard is getting harder and harder to meet every few years until we get to a point where we get to net zero, nearly net zero, with a really good envelope, really low loads in the building, et cetera. And so they've done all this work to say, okay, if we're going to get to this Tier 4 Toronto Green Standard, which is our nearly zero building, what is the increased capital cost? And you can see there that depending on the tier that you're going for, the capital increase they've sort of set at around 2 or 3%. The one interesting thing I'll point out here is that you see that the overall increase in capital cost actually goes down from Tier 3 to Tier 4. And basically what that's representing is the fact that once you make a quantum leap into a really good building envelope, your requirement for a mechanical system actually comes down significantly. So there's actually cost savings there. So some really interesting data that you guys can take a look at and start to put into your models. And then finally, once you have all these pieces together, you can start to do some really cool stuff with parametric analysis, right? This isn't something that you guys should be throwing darts at when you're thinking about doing design. You can actually model all these systems out. You can put these capital costs and life cycle costs associated with all these designs into a model and figure out what the optimal solution is. So one of the topics obviously of this conference is local solutions, and so I just want to spend a minute here talking about the work that I'm doing now. And so I kind of told you my background was in this net zero world, and that's kind of what I'm working to get toward and bring to the market. And so I work with a group called Subterra Renewables. And at Subterra, we're ultimately trying to change the way that we heat our buildings in North America. I showed you that stat at the start of the presentation here, where our buildings in our cities are using over 50% of the energy, and of that energy, most of it is heating energy from natural gas boilers. So we're really trying to change the way that we think about how we heat our buildings and cool our buildings, in fact. And so the solution that we're proponents of here is geothermal heating and cooling. And just to give a bit of a bit more in-depth description of that, we're basically partnering with developers who are building new projects, and we're saying, okay, instead of putting in your conventional boiler and chiller, let's put in a renewable energy system. Let's put in a geothermal system, which basically entails drilling a number of holes quite deep into the earth, 500 to 800 feet. and using that earth as sort of a heat battery over the course of a year. So in the summertime when we need to cool the building, we remove that heat from the building and store it in the ground. In the wintertime, when the building needs heat, we take that heat back out of the ground and put it back into the building. And again, I said, these systems relative to a boiler are 4 or 5 times more efficient, which results in a 60 to 80% reduction or savings in our heating costs. And again, not only are we getting that efficiency, that energy efficiency bump, we're getting a big bump in our emissions because we've fuel switched from natural gas to electricity. And of course, in Ontario, we've got a rather clean grid that can provide that electricity. So again, a lot of momentum, pushing us to this solution. I mentioned the Toronto Green Standard before, and I'll mention it again here. This is kind of the snapshot of where we are today. We are in the Tier 3 regime, where things can still sort of be met with status quo, the old way of building. But as we start to get into the next cycle being 2022 and certainly on to 2030, you speak with the smart energy consultants, and they'll tell you have 2 options. Okay, if you want to get to the next level here in 2022, you're going to have to either put triple glazed windows in all of your buildings, which is big money, or you're going to have to go to a heat pump solution to get there. And so this is one of the things that we feel we're even still a little early into the market, but once 2022 hits, this is going to be the way that all of our buildings are going to go, and certainly we're going to be ready to take that on. And so again, there's big push socially, politically. This is a standard that you need to hit to actually build a building. So what's the challenge? Well, again, this big challenge is always the economics for us. And so what we do at Subterra is basically offer a third-party utility model. And what that means is that once we partner with the developer, we basically put up the financing for that system. We own the system over a long-term contract. We operate it. We make sure that the field is operating correctly. We maintain all of the components. And on the building side, the apartment tenants or the condo owners effectively get to live in a building with a green system. They've hedged against fuel escalation costs. And really, the way we like to put it is that they kind of get the Cadillac solution for the price of a Toyota, right? It's helping us get over this friction of the economics of this solution, because we know that this is the right way to go. And so this is an example of the kind of stuff that we're doing right now. This is a project that we've just finished up. We're kind of at the single building scale, but we've got some proposals out that are looking at community plans, sort of district solutions where we can have one ambient loop, meaning that the temperature of this water is kind of at or around maybe room temperature, plus or minus a little bit. And once we've got this ambient loop running, we can start plugging in multiple buildings in, right? And some of those buildings are going to ask for heat, some of them are going to ask for cooling. All of those are going to sort of balance each other out on that loop. And then once it does go out of balance, we can start to add heating sources or sinks to that, like drilling geothermal wells, or one of the other things that we're excited about here, for example, is wastewater heat recovery, which otherwise would have been wasted, but we can basically grab the heat out of it and distribute it into our building, or vice versa. We can take the building, heat out of the building and put it back into the heat. So, this is really kind of the future direction that I think most buildings are going to move is not only low carbon solutions for heating and cooling, but also starting to think about district solutions and load sharing with some really innovative ways to put heating and cooling onto that. So, to kind of wrap things up here, there's nothing technically stopping us from reaching these solutions, right? We have the answers. We know how to get to zero carbon. It's really on us to sort of take responsibility of the problem, get out there and actually implement these strategies. And I'm hopeful that you folks in the room will sort of pick up the torch and carry that forward. So that's all I have. Thank you guys very much.
Many thanks for that, Matthew. You've given a heck of a lot to think about there. One of the And you mentioned the potential rise in average temperature by 1.5 to 2 degrees. But I think what people often forget is that doesn't mean that a high of 33 today may be 35 tomorrow. It may actually be closer to, say, Phoenix's 45, because what it means is that the range of temperatures starts to go out of whack. And so what is somewhat bearable becomes completely and totally unbearable. If you've ever been to California or Arizona in the hot months, you simply can't go outside
Totally.
if you're not familiar with that kind of temperature. I did want to open this to questions from the audience. Do we have any to begin with? Yes, sir. Fire away. We'll bring the mic to you. Hold on a minute. Okay.
I want to know more about passive solar heating. Can you explain it?
Sure, yeah. So obviously the sun has a ton of energy, and oftentimes, is just going to waste in our buildings. If you want to think about passive solar energy, it's really about designing your building from an architectural standpoint, meaning getting the orientation right. So in our position, that means putting a lot of windows on the south facade, not so much on the other facades, and then getting your massing right. So your orientation, your massing, meaning that can you get a broad side facing that south so you can let a lot of light in. And then the other piece of that is sort of not once you go beyond the massing and orientation is down to the envelope level, thinking about, okay, what kind of glass am I going to use in that glazing? Am I in a cold climate where I want to let lots of that solar energy in? If so, select a window with high solar heat gain coefficient. If I'm in a hot climate where I'm trying to think about minimizing my cooling, you might pick a glass with low solar heat gain coefficient and effective shading, right, on your south side and on your west side of your building. And then, that's kind of the last piece of that is thinking about strategies to absorb that heating in the wintertime when you would otherwise be heating with your mechanical system, and blocking that solar energy in the summertime when you're trying to cool the building.
One of the great things. There we go. One of the great things about some of the things that Matthew showed us is that the college system actually is kind of, each of us is pushing each other. So he showed some examples from Mohawk and Humber College. Seneca has a deep water kettle lake at its King campus, and we're installing or have installed a geothermal system to take advantage of that. So not only does that lake then provide a setting for our recreation programs, but also our underwater diving program, but now it's starting to have a functional purpose in terms of energy production as well, because we know that air conditioning needs generate as much or more energy need than some of our heating needs. The other thing I wanted to point out, and Andrew's done a great job of this year, is that we've got all compostable materials for eating on, and so there is the compostable. Yes, let's hear it for him. Great. And the other thing is, and maybe you could flash that offsets. Matthew talked about offsets and the use of offsets, and so we wanted to just talk about some of the offsets that Andrew and his people have been able to do in terms of meeting some of the requirements of putting on an event like this. So do we have access to that slide? Or do we not? We'll find out in a minute. In a minute, okay. So this is actually a picture of it. More questions, observations, comments, please. Yes, sir. We'll bring the mic to you.
In the 70s, 80s, and 90s, there's a big push for combustible energies. And now, even myself, when I go to change my energy consumption to something else, I get resistance. So how do I combat that? How do we get around that? I mean, there's resistance. I appreciate what you're saying, and I'm okay. But every time I go to make a move for that, it's like, oh, well, now you got to jump through this hoop and this hoop and this hoop. So how do we get through that?
So I guess, two points out on the macro scale. Certainly there's been a large move to go away from coal, and certainly there's been some replacement of coal with natural gas. It's a cleaner burn. And there are many reasons for that beyond the carbon emissions. And one of those is kind of the ability to ramp quickly, right? The nuclear kind of hums along at a steady pace. Same with the hydropower, whereas that combustion can start to ramp very quickly. So, at the macro scale, can we start to replace some of those combustion pieces with biomass or biogas at kind of the sorry? Or electrical, yeah, sure, that's right. And then at kind of the building scale, there's folks like Enbridge who are obviously in the business of keeping you on gas, and I think that there's sort of this push and pull dynamic, and I guess I'll use an analogy of let's look at a Tesla, right? Everybody, and thankfully we've had a market drive from Tesla to make cool cars that people want to be in. But if you go and buy a Tesla, it's no good if you don't have a charging station, right? And so these things kind of have to move in a leapfrog manner. And so you'll see the City of Toronto right now, again, in this Toronto Green Standard, one of the requirements is that for new buildings, you have to have 20% of the parking stalls with EV charging stations, with rough-ins for the rest of them. And so, they have seen the market demand for electric vehicles, so they put in the infrastructure, and that infrastructure will drive more demand. And so I would say there's kind of a similar analogy on the fossil fuel heating side, where certainly we've had a lot of push over those years to be in the business of natural gas, but I would say it kind of takes some brave folks to kind of lead the way and say, no, we do want to have clean sources, and we do want to have heat pumps. There you go, yeah, exactly, and that'll sort of get the market response. And even folks like Enbridge are certainly looking at alternative energy solutions. I just saw a presentation 2 weeks ago at the Sustainable Green Building Festival from Sustainable Buildings Canada, and they're doing some really cool stuff in hydrogen production, and they're certainly keeping their eyes to the market. So I think there's sort of this push and pull that you need to respond to. So yeah, certainly, I mean, put up your hand, talk to whoever, and demonstrate what you're interested in.
And as you can see up here, the offsets that Andrew Wickham and his people were able to identify for this holding this event. Any other further questions, comments, observations, brilliant insights, middling observations, whatever? Yes, sir. We'll bring the microphone to you.
Okay, check. Okay. It's great that institutions are taking the initiative to do this first, but with a declining dollar, our economy is not doing that well either. We have trading issues. Like you said, it's really hard for people to afford this kind of stuff. So, you can put the numbers on the chart, and it's easy to read that, oh, it's just a few $1,000s here, a few $1 million there. But the average Joe doesn't have time or money to put in efficient windows in their houses or buy a Tesla and get a charging station and do all the stuff. So I guess my main question is how could we afford all of this if it's so hard to?
I 100% agree, and that kind of to the point of the birth of Subterra and what we're trying to do. That is one example of the way that we're trying to get around that. So obviously, if you're going to go put in a ground source heat pump, the cost up front of that is 2 times as much, and so initiatives like ours are offering that clean solution for basically the same price that you would have paid for the natural gas. But I certainly understand your point, right? When you do the numbers and look at paybacks of changing your windows out, the economic case is usually not there, and so we start to look at a few things, right? Can we get market demand up so that those technologies can approach market parity with the traditional technologies? Photovoltaics is a big example of this, where the cost per kilowatt installed was much greater than fossil sources. Now we've seen that start to come down as demand goes up and production goes up. So that's an example of something that we can. Yeah, go ahead.
For the deadline that we're supposed to meet, do you think that time frame is even realistic enough to where we could make that an affordable price? Because we're kind of pushing.
Well, I mean, strictly from a photovoltaic standpoint, that's not the answer, right? The big answer, or one of the big answers that we need to do in terms of the building sector especially, is start to address our grid, right? So at a big scale, we need to eliminate coal so that we can start putting clean energy in. That's if you look at the trend of Ontario over the last number of years coming down, it's largely in part of getting off of our coal. And then the other big one is addressing existing buildings, right? So even if we were to put all of our new buildings net zero online now, we need to start targeting those existing buildings.
What about technologies that actually capture carbon? There's more thinking on those terms now. What are some of the initiatives that we're seeing in those areas?
Not my area of expertise, but I think that's sort of stuff that's happening at the plant level. I think, for example, Markham District Energy has working on a partnership with folks that are going to do scrubbing in their district system, because it's very natural gas intensive. But yeah, I think there's those sort of pieces that are working.
We're going to take a bit of a break now. I want to thank you, Matthew, for this. It's been brilliant.
Thanks so much for having me. Yeah, it's great.
My colleague Andrew Wickham has a small thank you on our behalf, all completely carbon offset. And what else does it demonstrate, Andrew?
Well, no, so thank you very much again. So a small gift of just our local Seneca honey from our local apiary.
Great.
Some treats that are, semi-well sought after and everything. But, and then part of the gift was also the carbon offsets as well. So we funded, the wind farms, clean water, forest planting, biomass, and it calculates about 24 tons of CO2 to try
Beautiful.
to neutralize our carbon footprint for this event.
I love it.
So anyways, thank you very much again.
Thanks so much.
Very much appreciate it.
Great. Thank you, guys.
So I'm sure Andrew and Matthew will be sticking around for a few minutes over the break period. We're going to take about 15 minutes, and then you're going to come back. My colleague Chris Dudley is going to lead us through an exercise that you're going to be involved in. One final thing, the folks wearing the Green Citizen T-shirts through our incredible sponsorship and support from TD Insurance, they're all in the project management and the environment program, and they're just they've been tremendous supporters of what we're doing here in the program. And so if you get a chance, just thank them for all the work that they're doing on behalf of putting this event together. We'll see you in about 15 minutes.